Hello, welcome everyone. We have already done the probability. Today we'll be doing the worksheet. This worksheet you can access on Akzsi app, whose link is already there in the description box. So let me start with the first question. The question 1 says the probability that Stephen building a brick wall in 10 days is 1 over 5 and building a stone wall in 10 days is 1 over 6. These both are independent events. Draw the probability tree diagram to represent this information given. It says that Stephen is building a brick wall and the probability that he will complete this within 10 days is 1 over 5 and building a stone wall in 10 days is 1 over 6. So we have to draw the probability tree diagram to represent this information. So we can draw like this. Let me make a two section. This is for building brick wall and this is for building stone wall. Within 10 days, either he'll be able to complete it or not. So probability of completion of this is that he will complete the brick wall is 1 over 5. So not completing will be 1 minus 1 over 5 because I have already explained that sum of all the events in a given experiment, the probability of sum of all the events of a given experiment is always equals to 1. That means when I flip a coin, I'll get either tail or head. So if I add the probability of getting tail and head, it will always be equals to 1. Similarly, here also, either he will complete or he will not complete. So probability of completion plus non-completing will be equals to 1. Similarly, I'll do 1 minus 1 over 5, which will give 5. Now the next is for stone wall. So suppose if he has already completed the brick wall, still either he can complete the stone wall or he can't. So probability of completing the stone wall is 1 over 6. So not completing will be 1 minus 1 over 6, which is 5 over 6. Again, since they both are independent events, that means the probability is not dependent on each other. So in either of the case, it will remain as it is. That means if 1 over 6 is given, so even though if he has completed the brick wall, the probability will remain the same. If it says they are dependent events, then the probability will get changed. So probability of completing is 1 over 6 and not completing is 1 minus 1 over 6, which is 5 over 6. This is a probability tree diagram. Now let me see the questions. Now the question says, find the probability that he completes both stone wall and brick wall. So what's the probability that he will complete both the stone wall and the brick wall? So I have to pick that branch which is or where he is completing the brick wall. So this is the branch where he is completing the brick wall. Now this is attached with these two branches. So from these two, just forget about the below ones because I have chosen this branch. So now I have to pick either this branch or this branch. Definitely I have to pick the branch where he's completing the stone wall as well because the question is where he's completing both the walls. So we have to pick this. That means probability of completion of brick wall and probability of completion of stone wall. This for stone and this is for brick. Clearly, according to the end rule, if there is n in between it, we have to multiply the probabilities. So probability of completion of brick wall is 1 over 5 multiplied by completion of stone wall is 1 over 6. Answer is 1 over 30. We have selected 1 over 5 and we have selected 1 over 6. Multiply them together. We'll get 1 over 30. This is our answer for part B. Part C says calculate the probability that Stephen could complete only one wall but couldn't complete the other wall. See, we have to find the probability where he is completing only one wall, either the brick wall or the stone wall. So we have two cases. Either he will complete brick wall and will not complete the stone wall, or he will complete the stone wall and will not complete the brick wall. These are two conditions. So if I interpret this in a mathematical format, probability of completion of brick wall. So probability of completion of brick wall, n, that means multiply probability of not completing stone wall. So n not completing stone wall is just a acronym that I have written. Or according to the or rule, if there is or in between the probabilities, you have to add them up. So plus probability of completing the stone. So probability of completing stone and probability of not completing brick wall. So probability of not completing brick wall. So let me select the branch where he's completing the brick wall. So this is the branch where he's completing the brick wall. This one I'm representing with a pin. Now I have to branch this one and this one, but I have to select where he's not completing the stone wall, which is this one. So probabilities are 1 over 5 here and 5 over 6 here. So 1 over 5 times 5 over 6 plus. Now I have to select the branch where he's completing stone wall and not completing the brick. So not completing the brick, that means I have to select this branch. This I'm representing with the blue. He's not completing the brick wall. Now I have two choices, either this and this, but I have to select that one where he is completing the stone wall, which is this. So here probability is 1 over 6. That means multiply them together times 1 over 6. So final answer will be, okay, now let me move on to the next question. 30 marbles are in a bag, 20 are blue, 5 are yellow and 5 are green. One marble is taken from the bag at random and not replaced. A second marble is then taken from the bag at random. Complete the probability tree diagram to represent this information. See, what's given that there are 30 marbles. 20 are blue, 5 are yellow, 5 are green. One marble is taken from the bag at random and not replaced. A second marble is then taken from the bag at random. So we have to remember we have three colors, blue, yellow and green. So what will happen? This is, we can divide it in the second, like two picks. This is the first pick. What will happen when he'll pick first time? And the second pick, what will happen when he pick for the second time? First pick, he will or he can choose three color. He can pick the marbles of any one of these color. Either he can pick blue, or he can pick yellow, or he can pick green. So probability of picking blue is, there are 20 blue marbles out of 30. So it will be 2 over 3 the probability. For yellow, there are 5 yellow marbles out of 30. That means 1 over 6 is the probability. And for green, there are 5 green marbles out of 30. So it's going to be 1 over 6. So this is a probability of picking blue, yellow and green in the first pick. Now for the second pick. In the second pick, also the three cases will arise. If he has already chosen the blue, this is when he has already chosen the blue. This is when he has already chosen the yellow. And this is when he has already chosen the green. So if he has already chosen the blue, that means now there is one less blue. One less blue, that means previously there were 20 blue marbles. Now there are 19 marbles. Out of previously there were 30 marbles. because he has already chosen one marble, so the remaining are 29 marbles. So the probability of picking blue will be, this is the case when he has already chosen the blue in the first pick. That's the reason now he has 19 blue marbles out of 29. Probability of picking yellow will be, previously there were 5 yellow marbles and still there are 5 yellow marbles. But out of 29, why 29? Because already there is one less blue marble. And probability of picking green is, previously there were 5 and still it's 5 because he hasn't chosen the green yet. It's just the after the blue out of 29. Now he has already chosen yellow. If he has already chosen yellow, so the probability of blue will be, still the number of blue marbles are 20. Obviously because he has chosen yellow. So why would the number of blue will change? So number of blue will remain same but total number will be changed. That is 29 since he has already chosen one yellow marble in the first pick. For the yellow, because he has already chosen one yellow, so there should be 4 yellow now. Previously it was 5, now 4 yellows out of 29. And number of green balls, previously it was 5, so it should be 5 now as well out of 29. Here probability of choosing blue, obviously the number of blue marbles will remain same, that is 20 out of 29. Probability of yellow is, previously it was 5 and still it should be 5 because he has chosen green in the first pick in this case out of 29. Now the probability of picking green is, since he has already chosen one green marble, so the remainings are 4 out of 29. So this is our complete tree diagram of the information that is being provided. Now let me see the question related to this. Calculate the probability that after the second pick, one blue counter and one yellow counter have been removed from the bag. So one blue counter and one yellow counter have been removed from the bag. That means after the second pick, or we can decipher that in the first and the second pick, they have already removed yellow and blue counter. That's the meaning. So we have to choose where he's picking blue and then yellow, or yellow then blue. So we have to focus on the two branches where he's picking blue first and then green, then yellow, and first yellow and then blue. So we have to choose, okay, so let I start with blue. I have to pick this branch, obviously, because he is choosing blue here. Blue, if he has already chosen blue, these three will be the possibilities. So I have to pick yellow in this case, 5 by 29. So what will happen that if he has already chosen blue in the first pick, the probability of choosing yellow in the second pick will be 5 by 29. Since it's a or in between, I'll add it. Now, this is the case where he's choosing yellow in the first pick and blue in the second pick. So yellow in the first pick, that means this one. And if he has done this one, then I have to pick any one from this three, which should be where he's choosing blue. That is, here he's choosing blue. So it will be 1 over 6 times 20 over 29. So this will be, if I simplify this, this will give me 3, this will give me 10. 87 plus 10 over 87, which will give you 20 over 87. This Now the third part says calculate the probability of choosing one blue then a yellow marble. Here they have specifically specified one blue then a yellow. That means only this case we have to deal with, this case only. Probability of blue then a yellow. So probability of blue is this one, which is 2 over 3, and then a yellow, that means this one. This is 5 over 29. That means 10 over 87 will be the probability. Now the fourth question is calculate the probability of choosing marbles of same color in both the picks. We can clearly see this table. That means I have to choose blue in the first pick and blue in the second pick, green in the first pick, green in the second pick, Yellow in the first pick and yellow in the second pick. That's how you will be able to choose marbles of same color in both the picks. So probability of choosing blue and probability of choosing blue in second pick. Plus, because it's or in between, that's why we are adding probability of picking green and probability of picking green again, plus probability of picking yellow and probability of picking yellow again. So probability of picking blue in the first pick is 20 by 30. In the second pick, it's 19 by 29. Plus of green is 5 by 30 and the second pick is 4 by 29. And similarly for yellow, 5 by 30 in the first pick and 4 by 29 in the second pick. So we can add and get our answer as this is 380 by 870 plus 20 by 870 plus 20 by 870, which is 420 by 870 or 42 by 87 is the probability. Now the question says, there are X shading pencils in a box. 5 are 5B pencils, 6 are 4B pencils, 10 are 3B pencils, rest are 8B and 7B pencils. Ron takes 3 pencils from the bag with replacement. See here it's mentioned with replacement. That means once you have chosen the pencil, then that pencil is being replaced. So the number of pencils will remain same exactly in the box. And the probability that he takes a 5B, then a 4B, then a 3B pencil is 1 over 90. Find the total number of pencils in the box. So it says that there are X shading pencils. So let me assume there are X shading pencils. He's picking and he's choosing first a 5B pencil. If I draw a probability tree diagram, you need not to draw all the 5 branches, then 5 branches, then 5 branches. It will definitely make your calculation, your whole thing very difficult. Don't do that. We know that if he's picking first 5B pencil, so probability will be how many number of pencils are there? 5B pencils are 5. So probability is 5 over X because X are the total number of pencils. Now after it he has chosen 4B pencil. Because pencils are being replaced, so X will remain exactly the same. Now number of 4B pencils are 6. So probability of picking 4B pencil is 6 over X. It will remain as it is because the replacement is there. Then after he has chosen 3B pencil. Probability of picking 3B pencil is how many 3B pencils are there? 10 3B pencils are there. And out of X, X remains same, total number of pencils will remain exactly the same. So probability of picking 5B pencil and so we need to multiply probability of picking 4B pencil and probability of picking 3B pencils is equals to 1 over 90 that is given in the question. Probability of picking 5B pencil is 5 over X, of picking 4B pencil is 6 over X, of picking 3B pencil is 10 over X, and this is equals to 1 over 90. 5 times 6, 30, 300 over X cubed is equals to 1 by 90. Cross multiply, you will get 300 times 90 equals X cubed, which is X cubed is equals to 27,000. X cube root it. When you cube root it, you will get your answer as 30. So total number of pencils are there. How many? It's 30 pencils are there in the bag. Lily has 2 pen boxes. In the first box, there are 10 red pens and blue pens. How many? 4. In the second box, there are 3 red pens and 5 blue pens. Lily takes a pen from the first box. Then she takes at random a pen from the second box. Work out the probability that Lily takes 2 red pens. See, what's given that there are 2 pen boxes. In the first box, there are 10 red pens and 4 blue pens. It's mentioned she then, that means this is how it's been said. She first have taken pen from first box, and then from the second box. The probability that she's picking two red pens, they both are independent events, obviously. We can just make a tree diagram. This is from the first box and this is from the second box. If she is picking red pen from the first box, probability is 10 over 14. Because how many red pens are there? 10 out of 10 plus 4, which is 14. And probability of picking blue is 4 over 14. She has already chosen. If she has already chosen red from the first box, for the second box, she will be having two different choices. Either she can pick red or she can pick blue. So probability of picking red is 3 out of 5 plus 3, that is 8. So probability of picking red is 3 over 8. Similarly, probability of picking blue pen will be, how many blue pens are there? 5 out of 8. Same I can say that if she has already chosen blue pen from the first box and now she wants to choose a pen from the second box, she'll be having two different choices. Either she can pick red pen or she can pick blue pen. How many red pen? They both are independent, so definitely the first pick or picking the pen from the first box hasn't changed the probability. It has no impact. So how many red pens are there? 3 red pens are there out of 8. And probability of blue, how many blue pens are there? 5 over 8. This is your complete tree diagram. Now let me see what the question is. Work out the probability that Lily takes 2 red pens. So I have to pick a branch of red pen and then a red pen. So I can say 10 over 14 times 3 over 8. This will be equals to, you can simplify, 4. 15 over 56. This is your final probability. Anna gets the train on Monday and Friday. The probability that Anna's train will be late on any day is 0.2. Draw the probability tree diagram. See, it will be late on any day will be 0.2. So, she's taking either on Monday and the second is she's taking on Friday. So, let me make the two ends for Monday and Friday. She's getting, or the train will get late, the probability of it is 0.2. So there are two chances. Either the train will be late or will be on time. So if it's late, the probability is 0.2. So if it's on time, it means it will be 1 minus 0.2. That's going to be 0.8. Again on Friday, because that's already mentioned in the question that on any day, doesn't matter on Monday or on Friday, the probability of getting late will remain same, which is 0.2. So if it's getting late, it's 0.2. So on time will be again 1 minus 0.2, which is 0.8. Again, for this, getting late is 0.2 and on time will be 0.8. This is how we can draw a probability tree diagram for this one. Work out the probability that Anna's train is late on at least one of these days. On at least one of these days means either the train will be late on Monday and on time on Friday, or on time on Monday and late on Friday. These are two possibilities. I have written in a sentence. Now, if I need to convert it into a mathematical expression, then getting late on Monday will be probability of getting late on Monday into on time on Friday plus on time on Monday into late on Friday. Now we have to add one more on this because it says at least. At least that means at least the train should be late on one day, either Monday or on Friday. But it can get late on both days as well. If it's getting late on both days as well, that means on Monday as well as late on Friday. So late on Monday is zero point 0.2, on time on Friday is 0.8, plus on time on Monday is 0.8 and late on Friday is 0.2, plus late on both days 0.2 and 0.2. So it's gonna be 0.16 plus 0.16 plus 0. Which is 0.36. This is your probability. Now the question says, a bag has 30 number of counters. The ratio of green counter to blue counter is 2:3. If a man picks two counters at random, find the probability of choosing counters of different color. So first thing is we have to calculate the number of green counters and the blue counters. If a bag has a total 30 number of counters, it's quite easy to calculate the number of green and blue counters. Let us say the number of green counters be 2x and number of blue counters be 3x. Then the sum will be 2x plus 3x is equals to 30 because total green and blue counters are 30. So 5x is equals to 30 and here x is equals to 6, which means green will be 2 times 6, that is 12, and blue will be 3 times 6, which is 18. Now we know that the number of green counters are 12 and number of blue counters are 18. Let me see what the question is. If a man picks two counters at random, that means he is picking two times. So for tree diagram, let me have the first pick and let me have the second pick. In the first pick, either he can pick a blue counter or a green counter. So if he is choosing or picking green counter, the probability of picking green counter will be, how many counters are there? 12 out of 30. And here probability of picking blue will be, there are 18 counters out of 30. So this is the probability when he will pick either blue or green in the first pick. But if he has already chosen green, again there will be two different cases. Either he can pick green or he can pick blue. If he picks green, so probability of picking green will be, since he has already chosen green, so there will be one less green now. So there are 11 green counters in the bag and out of 29 because there is one less counter in the bag now. Similarly, probability of picking blue will be, still the number of blue is same, that is 18, but now the total is 29. So probability of picking it will be 29. 18 over 29. Now if he has already chosen blue, again there are two different cases. Either he can pick blue or he can pick green. So probability of picking green counter will be, how many green counters are there? 12. But in the first pick, he has already chosen blue, so the total number of counters are 29 now. Probability of picking blue will be, since he has already chosen blue in the first pick, so there are 17 counters remaining out of 29. So this is the total probability tree diagram. The question is the find the probability of choosing counters of different color. That means if he is choosing green in the first pick, he has to choose blue in the second pick, or that means I need to add, if he is choosing blue in the first pick, he has to choose green in the second pick. These are the two possible cases. If he is picking green in the first pick, probability is 12 over 30. Then he is picking blue in the second pick, it's gonna be 18 over 29 because we have to see the color of different type, the different color counters. Plus probability of blue, if he is choosing blue in the first pick, that is 18 over 30. He has to choose green in the second pick, which is 12 over 29. So this turns out to be 216 out of 870 plus 216 out of 870. This will give you 648 over 270. This is your final probability. You can simplify it as well or leave it as well. In a city, if snow falls on one day, the probability that there will be snowfall on next day is 0.4. If there is no snowfall on one day, the probability that there will be snowfall on next day is 0.3. A man says there is 60% chance that there will be a snowfall in the city on Wednesday. Work out an estimate for the probability that there will be a snowfall on Friday. Clearly, it says that if probability is given, there will be a snowfall on Wednesday 60%. So we have to make 3 columns for Wednesday, for Thursday, and for Friday. And for Friday. For Wednesday, it says that there is a 60% chance that there will be a snowfall. So that means on Wednesday, either there will be a snowfall or there will be a no snowfall. So if there will be a snowfall, chances are it's 0.6, 60%, that means probability is 0.6. So if it will not occur, no fall, that means it will be 0.4, 1 minus 0.6. It says if snow falls on one day, the probability that there will be snowfall on next day is 0.4. So that means if it's fall on day, either there will be a fall or there will be a no fall. So it says if snow falls on one day, the probability that there will be snowfall or fall on next day is 0.4. So on Wednesday there was a snowfall. That means snowfall on next day, the probability is 0.4. And no fall will be 0.6. We are just working according to the question given. Now it says if there is no snowfall on one day, the probability that there will be a snowfall on next day is 0.3. So this is the case when there will be no fall on one day. So on the next day, there are two cases. Either it will be a snowfall or no snowfall. So snowfall will be 0.3 and no snowfall will be 1 minus 0.3, which is 0.7. Now again on Friday we have to make 3 because this will give rise to 2 another, this will give rise to 2 another, this will give rise to 2 another conditions, and this will give you 2 another conditions as well. This is the condition when there is a snowfall. So we know that if there is a snowfall, so next day there will be a snowfall possibility is 0.4. So snowfall, there will be 0.4. No fall, it will be 0.6. Now if there is no fall, next day there will be a snowfall possibility 0.3 and no fall possibility 0.7. Similarly, we are taking this one. There is a snowfall. Next day there will be a snowfall 0.4. No fall 0.6. No fall. Next day there will be a snowfall possibility probability 0.3 and no fall it will be 0.7. Now we have to see what they are asking. Work out an estimate for the probability that there will be a snowfall on Friday. So how can we make the possibility? See, it can be when there is no fall on Wednesday, no fall on Wednesday, then you can say no fall on Thursday as well, but there is a fall on Friday. We can pick no fall on Wednesday, fall on Friday, Thursday, and fall on Friday. We can pick fall on Wednesday, fall on Thursday, and fall on Friday. We can pick fall on Wednesday, no fall on Thursday, and fall on Friday. So basically, these are 4 conditions in which we will get there will be a fall on Friday. Let me find the answer. So no fall on Friday is what? 0.4. You can clearly see no fall on Friday 0.4. Then you have to pick this branch because you have picked no fall on Friday. So pick either fall, no fall. So no fall 0.7 multiplied by 0.7. And if you have picked no fall, then again there are two conditions, fall or no fall. So 0.3. Next is no fall, fall, fall. So no fall, 0.4. Then you have to pick either of this. You have to pick fall, which is 0.3. And if you have picked fall, so you have to go for this branch. And then you have to pick fall, which is if there is a fall. So 0.6 times. You have to pick fall here as well. So 0.4. And if you have picked fall, so you have to pick fall here as well, which is 0.4. Last is fall, that is 0.6 times. You have to pick either of these, that is you have to pick no fall, which is 0.6. And if you have picked no fall, you have to pick either of this, but you have to pick fall, which is 0.3. Now add these all up, you will get the final probability. This is the probability that there will be a snowfall on Friday. So that's it for today. This was all about the sheet. You can access all other sheets on Akzsi app as well. Thank you. Stay tuned.